my name is Irene Chen. I am a PhD student in electrical engineering and computer science. Right now, healthcare is, going through a huge change where a lot of machine learning is being prototyped and tested so that it can help doctors make better clinical decisions. Once we have a great predictive model that we can use in healthcare in this high stakes setting, how can we make sure that it's unbiased? And if we were to discover bias, how could we break down the sources, figure out exactly what is causing the bias? Is it the data? Is it the model? And so that we can hopefully make the algorithm unbiased. For our work, we look specifically at ICU, specifically predicting patient mortality within the hospital. One of the things that was incredibly surprising to me was that if you took a normal out-of-the-box algorithm that I just learned pretty naively as a first-year PhD student, I discovered that the subgroup accuracy, so for each different, let's say, racial group of patients based on self-identification from the patients, the accuracy is actually different for each different group. The question becomes why? A lot of hypotheses will pop up. Maybe it's the data. Maybe it's the model we're learning. Maybe we shouldn't be using a linear model. Maybe we should use something more complex. And the last possible explanation is actually maybe there's something noisy going on in the data collection process that sort of exists outside of the data we've collected, the model we've chosen, anything like that. Maybe it's actually beyond our grasp. And in that case, maybe tinkering with the algorithm all day or collecting a lot more data actually won't be helpful because we've decided it's the noise component of the data. Systemic inequity, which is sort of gets rolled up into this noise rate. So if people are not coming into the system as frequently, or they're not being measured in the same way, or if they have historical mistrust of different of healthcare professionals, that kind of gets all rolled into, hey, the data we see is not as clear as we would like. In statistics, we could separate this into statistical bias, variance, and noise, and thinking through all three groups and being able to break down our model into different components allows us to give a deeper understanding of what is at face value an alarming result, but now we can start to dig into what's going on.